Hello, everyone. We are Diana,
Matthew.
Claire?
Jonathan.
and we are students at UCLA in the Earth Planetary and Space Sciences Department. We are here to demonstrate what controls landslide hazards and provide you with the ability to determine where to build a dream summer vacation home. If you would like to participate in our at-home lab demonstration, be sure to have a parent present and the following materials handy.
Before getting into our lab demo, let's talk about what a landslide is. A landslide is almost exactly what it sounds like, when a piece of land or earth slides down a slope due to the force of gravity overcoming the force of friction. However, if you look at the world around you, lots of large boulders and trees and even buildings can hang off or be right on top of large slopes without sliding. This is because landslides will always have a cause, and oftentimes multiple, which allow the force of gravity to override other forces and bring earth and debris down the slope. If we think about the places in which landslides occur, we first have to think about the earth that is sliding. The ground all around us is made up of layers of different kinds of rock, like the granite on your countertops and the mudstones and shales that form in the bottom of lakes and oceans. Over time, layers of different rock are deposited one on top of the other. And because layers are made up of different rock compositions, some are weaker than others. This weak layer is the place and plane where sliding occurs when something disturbs the layers above. For example, if you have a steep slope and get a lot of heavy rain, that rain can lower the amount of friction on the weakest layer and let gravity take over. Bam, you have a landslide. So what kind of events can trigger a landslide? As I mentioned before, rain is one of the many causes. So is snow, changes in water level, earthquakes, volcanic activity, human activity, and more. And the speed at which the landslide travels also depends on the cause and how steep the slope is. Some landslides can creep very slowly. It can take years for the movement to even be noticeable. And some occur instantaneously, as fast as the snap of a finger. Now, landslides can have a lot of variation, which, as we talked about before, can depend on the kinds of rock, steepness of the slope, and cause. So it's time for us to do a fun demo. In this demo, we are going to be looking at how sediment size changes two different factors. First, how much of a trigger, in this case rain or water, is needed to initiate a slide, and second, how much damage that slide causes. Inspiration for this demo was taken from the University of Colorado Boulder's Teach Engineering program, and this slide contains the link to the model house template that was used in the demo. As Diana mentioned at the beginning of the video, now is the time to grab your supplies if you'd like to follow along, pausing where needed. It's time for the landslide demo. First, let's talk about the materials you need to recreate this demo at home. All of these items can be found at stores like Target or the Dollar Tree if they aren't available in your home already. First, you'll need 2 cups. Then, a piece of cardstock or cardboard. A waterproof container, preferably with a flat bottom. Some parchment paper. Tape. Duct tape. Scissors to be used with adult supervision if needed. A model house template. And then your landslide materials. I'm going to be using a fine grain sediment, a medium grain sediment, and finally a coarse grain sediment. I got the coarse grain sediment from the Dollar Tree and the other 2 from my backyard. Now let's set up our materials. First, take the model house template and build some cute summer homes. I'm coloring mine pink and going to cut it out using the scissors. You want your houses to be around the size of a quarter and can use any template or even create your own. After cutting out my house, I'm going to be folding it and taping it all together. You can build 3 or 4 houses to put at different locations in the bottom of your waterproof bin to watch how they are each affected by the landslide. Coloring each house a different color can help you keep track of your results. Here is my finished neighborhood. Now let's build our ramp. Fold and cut your cardstock so there are 2 small brims on the side to prevent material from falling out. Then attach a piece of parchment paper to the center with tape to prevent the ramp from getting soggy. This ramp should last throughout the entire experiment. Next, we can use the duct tape to attach the ramp to our bin and cup. The ramp and bin will need to be cleaned after each slide, so you only need enough tape to keep the ramp in place while you are using it. As you can see here, I'm using one piece of tape at the top and bottom to keep my ramp in place. Our final step before we start is to put our neighborhood in place. I am placing my 3 houses at slightly different distances and locations from the bottom of the ramp to see how they are affected when the slide begins. It's finally time to start our demo. Let's start with the fine-grained sediment. I'm using a spoon to help me scoop the sediment to put at the very top of the ramp. Put enough so that the sediment will not slide before you add your water. I'm using my hand to help me balance the sediment at the top and catch some of the grains that might have slid too early. As you can see, some got away from me, which is totally okay. Once you have your sediment situated, go ahead and start pouring some water. Watch the landslide occur as you pour water and see how it affects the neighborhood you created below. Was your summer house safe? Next, we are going to repeat the process using the medium-grained sediment. As you can see, I've cleaned the ramp and bin before starting this trial. Go ahead and get your sediment situated at the top of your ramp, just like we did with the fine-grained sediment. Now, time for the water to initiate your landslide. Does the medium-grained sediment need more or less water to start the slide? And look what happens to your neighborhood below. Is there more or less damage? Finally, let's repeat the process one more time using our coarse-grained sediment. Go ahead and get your coarse grains situated at the top of your ramp. And now it's time for your landslide. How much water does the coarse grain sediment take to slide compared to the medium and fine grain? And how much destruction to your neighborhood occurred?
Clear's experiment shows us some of the parameters that can make landslides more or less likely to occur. Decreased slope, increased cohesion, say from vegetation growing on the side of the slope, will make the slope more stable, while increased precipitation will instead reduce how well bound sand, dirt, and other particles are to each other, making landslides more likely to occur. Landslides are dangerous events and predictable from the parameters Claire discussed. But how can we apply this knowledge and analyze something practical? Well, how about constructing your dream summer home? Homes are not always built in the safest areas, and knowing what environmental factors to look for in these environments can help keep you safe. Because your home can be full of fun or dirt. Let's look at these example environments here.
First, we have a photo of El Capitan at Yosemite National Park in California. It is important to acknowledge that Yosemite National Park is rightfully home to the Awanishi natives who were driven to reservations during the time of the gold rush in the mid-1800s by a Euro-American militia named the Mariposa Battalion. History of the Awanishi tribe is visible throughout the park and should be respected at all times. Although real homes should not be built here, we use this location as an example environment. Second, we have an image of Burgundy, France. This environment is a shallow sloped farmland.
Third, we have an image of Shilin Gorge, Hubei Province, China. There are steep slopes and some vegetation in this area, and it looks like there's a lot of exposed soil too. Finally, we have an image of Uttarakhand, India. There's even more vegetation and slightly shallower slopes in this location. Which location would you choose to build your house based on our experiments and factors we have seen to affect landslide probability? We'll give you a few seconds to think about it.
I think Uttarakhand might be a good location. There's a lot of vegetation to keep the soil from sliding down.
I agree, but what about the amount of water in the ground? Maybe there's an abundance of vegetation because there's a large degree of precipitation here, and that isn't good for landslide safety. What about the Ubei province?
The ground doesn't look as wet, but the slope is way too steep. And the soil looks fine grained too. If it rained here, I would be nervous that the water would mobilize the loose soil. I think Burgundy, France would be the safest location to avoid a landslide.
Hmm, I agree.
Me too.
Yes, Burgundy, France is the safest location. Although this location might receive a lot of rain and have looser soil, it has shallow slopes, so the factors are less influential for a landslide hazard. What about Yosemite? Can somebody explain why El Capitan would be likely to experience a landslide?
Well, I've studied glaciers in class before, and I know this location has seen recent glacial melting approximately 15,000 years ago. Glaciers form in environments where more snow accumulates than melts. The snow compresses, becoming denser and more tightly packed. Glaciation will cause freeze-thaw conditions, which means the bedrock will expand and contract, creating weaknesses and fractures. This is the perfect setting for a landslide to occur because the bedrock is weakened. The accompanying changes in climate, such as the potential increase in rain, steep slope, and loosening of sediments, makes this location more susceptible to landslides overall. So we cannot safely build here.
Dana, those are great observations tied into previous knowledge of the area. There are always more information beyond these photos that will provide a holistic understanding of the environment. Now we have a summer home location safe from landslides, on Earth at least.
Now, one of the coolest parts about how we understand landslides is that it lets us watch out for them anywhere, even on other planets. Think about everything we've learned about landslides so far and what causes them: snow and rain, earthquakes, even volcanoes. Those things can sometimes happen on other worlds too, rocky planets like Mars and Venus, even our own moon. And so, just like we have to make sure that we build on safe, stable ground here on Earth, we also have to watch out for landslides when we go exploring in space. Let's start in our own cosmic neighborhood, on the moon. When astronauts first went to visit, they saw lots of evidence that the surface of the moon wasn't so stable. See here? This is a picture of an astronaut named David Scott, right in front of a ledge called Hadley Chasm. And you've already learned that steep slopes mean landslides. You can already see right behind the astronaut where there's a big pile of rocks and moon dust and all kinds of debris that must have come down from higher up the ledge. Now, if it was your job to drive a heavy car around on the surface of the moon, how safe would you feel driving right along the rim here? I think if it was me, I'd want to back up a little bit. And when we look at the moon from further out, using satellites and telescopes, we see that there have been lunar landslides all over the place. Can you see where bright streaks show how dust and rock have moved down these slopes? Even though the moon is very still compared to the Earth, with no liquid water or even any air, there's still just enough going on up there for landslides like these to happen, even very big ones. Of course, that's nothing compared to what we see on some other planets like Venus and Mars. Check this out. That's a landslide that's more than 50 miles across, from the side of a huge canyon called Valles Marineris on Mars. It could have taken out an entire city. Mars is a lot more active than the moon, with ice and frost, strong winds, and dust storms that can dislodge rocks and cause these huge collapses, even though there's no liquid water in the pore spaces. And far back in history, billions and billions of years ago, it even had lakes, rivers, and rain, just like Earth. And that means ancient Mars had even more landslides than it does today. So some of these landslide deposits that we see are incredibly old. We're exploring Mars more and more, and we may even start building there in your lifetime. Who knows, maybe you'll even play a part in the construction. So taking what you've already learned here today, which of the following places would you feel safe building in, and which might be in danger from landslides?
Would Mount Sharp work? The Curiosity rover has been there for a while, so maybe it's stable there.
I'm betting it's Jezero Crater because the ground seems very flat right around it.
Lombe Hills seems pretty steep to me. That might not be the best place. What do you guys think?
Remember, the rules for landslides on Mars are exactly the same as they are on Earth. We don't have to worry about liquid water so much, but volcanic eruptions and earthquakes can still dislodge weak layers of rock and allow the weight of rocks further up to collapse. So sites like Columbia Hills and Mount Sharp aren't fully safe. Jezero Crater is probably the best. And if you think about it, this is really amazing because we understand how landslides work on a deeper level. This gives us the ability to make responsible choices about where we want to live or where we want to explore, even in a very alien place.
So whether you're exploring new planets or just your backyard, we hope you've learned something about the ways that the ground under your feet might not be quite as stable as you thought. Good luck out there, and stay safe.